Hello, welcome to the Spence Movie Theater. Just joking. Thought that you would get a kick out of that. Start off with a little funny. Let's move on. I went ahead and cut out my notes. I noticed that they're not in the same order as they were on that page. So what I want you to do is I want you to kind of eyeball these, and I want you to get everything cut out so that way you've got it all ready to go for the video. So just freeze the screen as you need to, just so you can see what to put on the first page, and then freeze the screen and see what you need to put on the second page. So do that for me and come back when you're ready and you've got everything taped down. Alright, the other thing that you might want to do is this first direction says use a protractor and a ruler to draw two non-congruent triangles so that each triangle has a 40-degree angle and a 60-degree angle. Then measure and label the third angle side lengths. So you can see here that I've already done that. I measured this out. You can see there that that's a 40-degree angle. And over here I've got a 60-degree angle. You can even see where I marked that. And then I measured this to be 4 centimeters. And you can see right there it's 4 centimeters. And I went over here and decided I would make this one 6 centimeters just for fun. And of course my 40 and my 60. So we're supposed to show that these are similar. So we're going to, first of all, we know that since these add up to 100, this has to be an 80-degree angle. Alright, because they all add up to 180. So all I need to do now is just measure the side lengths. So I'm going to measure this at approximately 3.5 and this at approximately 2.7. Now remember, I'm just measuring this, so unfortunately a ruler is an estimation tool. This looks like about 5.5 centimeters, and I would say this maybe at 4 centimeters. Alright, well anyway, those are estimations, and since the ruler is actually an estimation tool, to find out if the triangles are similar, they have to meet the definition of being similar, which means that all angles must be congruent, which they are, so that's good, and the sides have to be proportional. So that's what we have to check. So we're going to start off by looking, let's letter these. This is triangle ABC, and we'll name this triangle DEF. So let's check to see if the sides are proportional. Let's check AB and compare that to DE. So 3.5 compared to 5.5. And we want to check that to make sure that it equals AC over DF. AC over DF is 4 over 6. Whoops, that's a 6. And then BC, we want to compare that to EF. So 2.7 over 4. Notice I went little to big, little to big, little to big. Stayed consistent all the way through. Now I know 4, 6. I have that memorized. That's 2/3, which is 0.6 repeating. That one was an easy one. This guy right here, 3.5 divided by 5.5. Looks like very, very close, 0.63 repeating with a line over that. And then 2.7 divided by 4 looks like 0.675. So you can see that if there was truly similar, we would have to get exactly equal measures all the way around. Now, I would imagine that because I used a measuring tool, a ruler, my estimation tool, that is probably why they came out not exactly the same. But they should. They have to come out the exact same ratio all the way around in order for them to be similar. So very, very close, and you can decide whether or not you want to call those similar. All right, now we're going to see that we don't have to check all the angles and all the sides. Do you remember back to our congruent triangle chapter, where to show triangles congruent, we had to show congruent triangles, we had the side theorem, we had side, angle, and let me think, am I missing one here? Angle, side. Those showed triangles were congruent. Well, it just so happens that we've got the same type of thing for similar. And we've got a couple postulates. Here's our first postulate. This one seems like a no-brainer. If two of the angles are congruent to two of the angles on the other side, then you know for sure that the triangles are similar. Not congruent, you know the triangles are similar. Because you know as well as I know that if I have an equilateral triangle, which is 60, 60, 60, 60, and then I make another one that's 60, 60, 60, you know as well as I do that those triangles are not congruent, but they're definitely similar. So all it takes to be similar is to have two of the angles congruent to two angles on the other side, on the other triangle. And we have similar triangles. All right, here's another couple theorems that we've got that come from that. You've got the side similarity theorem. This theorem says that all you have to do is check to make sure that all your sides are proportional, then the triangles are similar. Make sure all your sides are proportional. That's all you have to do. The side similarity theorem. So close to that side congruence theorem that we used back in the different chapter. And then theorem 8.3. What? You're telling me all I need is side, angle, side, and I can prove that they're similar? I thought side, angle, side proved that they are congruent. Well, this side, angle, side is a little bit different. What we're saying is that the angle between them is congruent, but the sides are proportional, not congruent. So in other words, if I can get xz proportional to MP and xy is proportional to mn, in other words, if this ratio is equal to this ratio, then I have similar triangles. So if this side over this side equals this side over this side, they're not the exact same measures. We want to check their fractions, and we can make sure that the angle between them is congruent. Between them, you can't just use any other willy-nilly angle you want to use. You got to use the one between them. And if it's congruent and the sides are proportional, then you have similar triangles. All right, here is a proof of theorem 8.2, which I am going to let us discuss in class. Okay, please make sure that, let's just write a little note here. Don't want to forget this. Discuss in class. So that way we know to discuss that. All right, let's turn the page and do some example problems. Haha, this is just a funny. How do similar triangles weigh themselves? Answer, with their scale. Haha, that's how they weigh themselves, because they have a scale. Haha, that was a funny. Well, you may not have thought that was funny, but I'm sitting here just laughing. All right, let's go on. Suppose that suppose a company logo, as seen at the right, uses equilateral triangles and circumscribed and inscribed circles. Circumscribed and inscribed. Remember, inscribed circles are the ones on the inside. Circumscribed are the circles that are around the outside. Are these two inscribed triangles similar? Why or why not? This triangle is definitely similar to this one because their sides are proportional and their angles are congruent. You can see that they are equilateral. All right, so yes, sides are proportional, and angles are congruent. Sides are proportional and the angles are congruent. So we know that they are similar. If the measure of one side of a large triangle is 4.5, so I'm going to write that here, and the scale factor between the two triangles is 5 to 2, what is the measure of the small triangle? All right, if I know the scale factor is 5 to 2, I'm going to use that in my proportion. 5 to 2. Now that's big over little, so I want to put the large number over the little number, and we don't really know what the little number is, so I'm going to let that be x. All right, if I cross multiply, 4.5 times 2 is 9. 5 times x is 5x. And when you divide both sides by 5, x equals 1.8. And that is the length of this side right here, 1.8 centimeters. Now, the next example says find the height of the flagpole. And yes, you can do this. You go stand outside and you look at your shadow, okay? You measure your shadow. You know how tall you are, and you know how tall your shadow is. And you don't have to be standing like this next to the flagpole. You just have to pay attention to where you are and where your shadow is, and you measure those. Then you go over and you, of course, are trying to figure out the height of this. You don't really know it, so we'll let that be h. But you measure the distance of the shadow of the flagpole. Say it's 24 feet. So do you see how that makes similar triangles? So we know that your height over your shadow equals the height of the flagpole over its shadow. U over shadow equals U over shadow. We multiply 8h, that's cross product, 8h, and then 5 times 24. 5 times 24 is exactly 120. We're going to divide both sides by 8, and that gives us a height of 15 feet. Alright, let's move on to the next example. To comply with the American Disabilities Act, wheelchair ramps made for new constructions must have a height to length ratio of 1 to 12. At a new construction site, the height h of a new door is 2.5 feet. So that's going to be this distance right here, 2.5 feet. So from here all the way to the top. Calculate the length of the ramp R using the given ratio. Alright, so here is your little wheelchair dude. He's got his wheels, and let's say he's sitting here in his wheelchair and he's trying to get up this ramp. And let me tell you, it is no easy feat to get all the way up that ramp. Alright, but we know that the ratio of the rise to the run of this should be 1 to 12. For every 12 feet this way, it can only rise 1 foot. 12 to 1. And so that's the ratio of this ramp, or what it should be in order to allow this wheelchair access. So we just have to figure out how tall we want this to be. So if the run is 12 and the rise is 1, of course this is the rise, we're going to put it on top with the rise here, and we're going to try to figure out how long this ramp needs to be in order to figure out this distance. So we cross multiply, 12 times 2.5, 12 times 2.5, we get 30. 1 times x is x, so we know that that should be 30 feet. 30 feet from C to B, alright, right here, 30 feet total, in order to get up to the door at 2.5 feet tall. Alright, moving on. given that you know angle CAB is congruent to angle CBD, how do you know that the triangles are similar? Explain your answer. Well, first of all, here's triangle CAB. That's the big guy. And triangle CBD is this guy right here. Those don't look similar to me. Okay, this triangle looks different to me than this one. But if you turn it, I bet you they would look the same. So if you took this guy out and you moved it here, then it probably would look the same. They're kind of overlapping right now. You've got this triangle that's sitting on top of this triangle. Alright, so you can see first of all that angle C is definitely going to be congruent to itself. If you want, it makes it easier for you, you can pull these things apart. Here's your triangle ABC, and then here would be your triangle CDB. CDB. So angle C, this angle right here, is definitely going to be congruent to itself. And angle A, you can see, goes with angle B. In the picture, you can see that those two are similar. So these two are similar, they're congruent. A is congruent to B right there. Alright, and so these have to be similar triangles by the, similar by the angle-angle similarity postulate. Okay, the angle-angle similarity postulate, and that's how we'll simplify that just a little bit. All right, moving on. Last one. Find the value of Z. Assume the triangles are similar. All right, if the triangles are similar, then I can write a proportion with this. I know that 14 goes with Z minus 4. They are corresponding. 14 over Z minus 4. You always put corresponding parts in the same fraction. Then 18 must go with 27. Now since I put 14 on the top here, I got to put 18 on the top here. Otherwise I'll get it all messed up. Alright, so I'm going to cross multiply here. 18 times Z minus 4, making sure to put Z minus 4 in parentheses. 14 times 27, let's just see, 14 times 27, the mathematical genius tells us it's 378. See, mathematical genius. So then I'm going to multiply or solve this. 18Z minus, what is 18 times 4? 72 equals 378. Add 72 to both sides. I'm going to do this on my calculator because I'm running out of room. Add 72 to both sides. That makes 450. And then I'll have to divide by 18. So the answer Z is equal to 25. Z is equal to 25. And that is how you solve that problem. Hopefully that helps. Y'all have a great day, and we'll talk at you later.